So here we're going to investigate some inelastic collisions, and we're going to use a simulation for this. Of course, if we had the physical apparatus we could do that, but we'll also discuss some of the differences that we would get with a physical apparatus to the simulation. So you will have a handout of this. So in front of you, you should see you've got a table which you can stick into your books and you can complete this. So the table has different columns in it with which we're going to put in some quantities into the table as we do the investigation. So here's the first column is going to be the initial velocity of the left cart. So this is the left-hand cart here, and we can put in a velocity. So the symbol for that is u1. So u is the initial velocity, and 1 just because it's the first cart. This is going to be cart number 2 on the right hand side. So if we put in for the initial velocity of the left hand cart, if we put that as 2, and if we put the mass as 4, we'll leave that as 4, and the mass of the right hand car, we're going to put that in as 5, and the velocity we're going to have as 0 to begin with. So these are going to be inelastic collisions. We're not going to worry about elastic collisions today. We're just going to focus on inelastic collisions. And in inelastic collisions, remember the carts will stick together completely. They won't bounce off each other. If they were elastic, then they would rebound off each other after the collision. So once they collide, they're just going to stick together and they're going to move off together, and that's called an inelastic collision. So we're going to write these in here. So the initial velocity of the left-hand cart is 2. The mass is 4. Therefore, the momentum, P1, of the left-hand cart before the collision. Remember how we calculate momentum? We calculate momentum by doing the mass times the velocity. So this is going to be 4 multiplied by 2, which gives us 8. Now the initial velocity of the right-hand car is 0. The mass of the right-hand car is 5. So therefore the momentum P2 of the right car before the collision is 5 multiplied by 0, which gives 0. Now the total momentum of the system has got to be the momentum of the left-hand car plus the momentum of the right-hand car. So the momentum of the left-hand car is 8, and the momentum of the right-hand car is 0. It's not moving, so it doesn't have any momentum. So the total momentum of the system is 8. Now, we can use this to find what the velocity of both of the cars stuck together is going to be. And in order to do that, we need to remember that the total momentum of the system is equal to the total mass of the system multiplied by the velocity of the two carts moving away together. So that means that the velocity of both carts stuck together, we can predict it by doing the total momentum of the system divided by the total mass. So the total momentum of the system is 8, and then we divide it through by the total mass. So in this case, that's 4 plus 5. So this gives us 8 divided by 9, which is 0.89. Let's just check and see if this is correct then. So we've got, this is our prediction. We're going to predict that the velocity is going to be 0.89 of both carts stuck together after the collision. So we can put our prediction in here. Oops. 0.89 and 0.89. And we can see then that it's going to, hopefully after they've collided, they're going to move off in a positive direction because this momentum is positive, and that means it's going to move off to the right because we've defined the right, anything moving towards the right as positive. Go!